Hey everybody, welcome to our office hour. This week, our topic is going to be quadratics. But before we do that, let's dive into our challenge problems. So, our first challenge problem has to do with a hexagon. So, first, let me bring a hexagon up here on the screen. And we're going to use this, to kind of visualize what's going on here. So the main thing with a hexagon problem is you really want to associate hexagons with 30, 60, 90 triangles. And the reason that is because if I make a triangle here, notice that this single triangle, if I go through and I recreate that triangle, so that's the big ones, and then I cut each of those in half. I'm going to get 12 of those exact triangles. And then what I really want is just this side here. And actually, before I say that, I want this angle. Well, what happens is that angle is duplicated 12 times and makes a full circle. So that's 360 degrees in total divided by 12. That's where I get 30 from. Okay, so this is a 30-degree angle, which makes this a 60. So I have a 30, 60, 90 triangle, and that'll always be true when it comes to hexagons. Then I do this. I say, okay, the whole thing has a perimeter of 108. It's regular, which means all the sides are congruent. And 108 divided by 6 is 18. So this whole side is 18, which makes this part of the triangle 9. Then we have to remember, or you don't remember this actually, you look it up on the reference sheet. And if I make that exact triangle a little bit bigger, kind of zoom in on it, and this is 60, and this is 30, and this is 9. The way it works is the side lengths of a 30, 60, 90 are x, x root 3, and 2x. So if this is 9, this is 9 root 3. And then this is 18, but we don't really need that. What we do need is the fact that we want the area of um, the whole entire hexagon. So the area of one of the triangles would be 1/2 base times height. So that's 1/2 base is 9 and height is 9 root 3. And then there are, like I said, 12 of those triangles. So I'm going to take this whole thing and multiply by 12. This one says nearest whole number. So if you put that in a calculator and round it, you should get 842. All right. So again, the key here is when you see hexagon, you need to think, okay, this is going to have something to do with a 30, 60, 90 triangle. All right, let's move on to number 2. So this one, if I look right at the question, there's also kind of a mistake in this problem, I realize. It wants the approximate percentage growth that company B experienced. It really wanted the monthly percentage growth. All right, so that'll kind of inform how we do this problem. So I still thought it was a good problem, so I left it on there, but I did realize that mistake afterwards. The actual percentage growth of the entire time, that answer choice is not here, so I can only assume that they meant monthly, and it's actually what I want to go over in this problem. Also, another thing I want to go over, if they want company B, let's just look at company B. So in January, company B had this many customers. And then we're going to ignore company A for now. And then in September, it had this many customers. Okay. So it started with 325,750 customers. And then each month we multiplied it by some value. I'll go over that in a second. When you increase something by a percentage or decrease it, you multiply it by a specific value. And again, we'll talk about that value. And I'm going to multiply it by that value month after month after month. So January, February, March, all the way up until August, actually, because this is September 1st. So it it's just basically the end of August, right? So we did all of January, got multiplied by some value. And again, that'll end up being 8 times. So if we multiply by the value 8 times, that's x to the eighth. Whatever value this is will get multiplied 8 times. That's x to the eighth. And then it led to having this many customers, 368, 462. So now what I want to do is I just want to solve for x. So divide each side by the 325, 750, and that'll give us x to the eighth equals. So it was 368, 462 divided by 325,750, and we got like 1.1311. And then to get x by itself, we would want to do the eighth root of each side, or you could raise it to the 1/8 power. So if we take the eighth root of that, we get about 1.0156. And then we have, so that's the value that we multiplied it by each month in order to go from the initial number of customers to the final amount of customers. Okay? So now what happens is we have to interpret this. So since it's bigger than one, it's a percent increase, which makes sense. It says percentage of growth. And then the way we kind of think about it is, well, it's this much on top of one or on top of 1%. So you kind of ignore the one, and then you move the decimal place over twice to figure it out in percentage form. So that's a 1.56% increase. Like if that doesn't make sense, imagine you had a 25% increase. You would change it to 0.25, and actually to multiply by something to include that percentage, it would be multiplying by 1.25. So hopefully we know that that's what a percent increase is. So again, we're working backwards here. We're chopping off the one and we are moving the decimal over twice. So it ends up being a 1.56 percentage increase each month. All right, let's move on to number one. So we're talking about quadratics tonight. And one of the ways to solve a quadratic is by factoring. So we're going to talk about the different ways to solve a quadratic throughout a lot of these problems, and we always have the option of using Desmos. All right. So they talk about C being a solution. Don't worry about that. This just means there is likely two solutions, and we want the solution that is positive. That's all that means. They're going to switch letters on you and do all that, but don't let that kind of get to you. Just know most quadratics have two solutions, and we just want the positive one. Now, again, you can throw it into Desmos and look for the x-intercepts and take the positive one. Or I want to go over tonight the different ways that we could solve a quadratic. And one of them is factoring. So we're just looking for two numbers that multiply to negative 90 and add to 1. And that's simply just going to be positive 10 and negative 9. And then you set each factor equal to 0 to get your two solutions. So your two solutions are going to be negative 10 and positive 9. And since they want the positive solution, the answer is simply just going to be 9. All right. So again, we could use Desmos here. That's totally fine. I know we all know how to plug into Desmos, so I'm going to be talking about like the other ways of doing it. And as always, Desmos, you should be using that a lot of the time, but there are questions where Desmos isn't really possible, so we do need to understand the concepts. So that's what I'm kind of doing here is telling you you can use Desmos, but also giving you the concepts kind of behind that. All right, let's move on. All right. So number two, how many real solutions does this equation have? So let's look at it from two perspectives. One of them, actually, yeah, I guess two different perspectives. One of them would be graphically. So if we use Desmos. So let's again review the concepts. If we want to know how many solutions it has, if it crosses the x-axis twice, then that's going to be two solutions. If it just hits the x-axis and bounces off, that's going to be one solution. And the other option is for it to just never cross the x-axis. So that's going to be zero solutions, zero real solutions. The other perspective is to use what's called the discriminant. So if you think about the quadratic formula, The part that's under the radical is b squared minus 4ac. And that could take on three values. It could be greater than zero. And if it's greater than zero, then we'll be able to take the square root of it, and the plus or minus will give us two solutions. If b squared minus 4ac is equal to zero, then you'll get the square root of zero, which is zero, and the plus or minus won't be necessary, so you'll get one solution. Or b squared minus 4ac is less than zero, and that's going to be negative, and you can't square root a negative and get a real value, so that'll be no solutions. So either throw it into Desmos and look and see how many x-intercepts it has, or use the discriminant. So again, I know we all know how to plug into Desmos, and that might be faster for you, but I just want to show you how quickly we can also just do the discriminant. So b squared, well, this is a, this is b, and this is c. Well, b squared is 9, and minus 4 times a times c, and that ends up being 9 minus 40, which is clearly negative. So since it's negative, there are zero solutions, zero real solutions. Okay. Now, number three. Number three, let's do a quick review of functions in general. So let's just say I was asked to find f of 2. Well, that would mean that I would replace whatever my input is, that goes wherever there's that same input. So in this case, the input is x. So f of 2 would really be 2 squared plus 2, which is simply 6, but that's not what's important. What's important is whatever is in here goes both here and here for this function. So it gets squared, and then you add it to the input. Well, if they're asking for f of x plus 2, it means I'm going to take the function, the input, and I'm going to first square it. So that's x plus 2 squared. And then I'm going to add x plus 2. So that's the first part of this. Well, notice that answer is not there, so we have to simplify. One way to simplify would be to actually square this out, combine like terms, and then refactor it. But there is a quicker way. We can just factor it right away. So these two terms have an x plus 2 in common. And then I look at kind of the reverse of the distributive property because I'm factoring out a GCF. And x plus 2 times another x plus 2 is where this x plus 2 squared is going to come from. And then I have this plus, and then x plus 2 times 1 is where this x plus 2 comes from. So I simply have x plus 2, and if I simplify what's in here, x plus 2 plus 1 is x plus 3. So that is answer choice B. All right, so just looking for that little like GCF, it's a little bit more of an advanced factoring move, is gonna save you some time. Okay, now on to number 4. If R and Q are solutions, again, they're just making up these other letters. Just there are two solutions to this. What is the value of R plus Q? Now, one thing is to just solve this and find the solutions. Some different ways to solve. One would be factoring, although I don't think this factors. Another would be completing the square. That wouldn't work out well here. We'll talk about that more later. Another would be quadratic formula. And then we could find the two solutions and add them together. Another would be using Desmos. Again, find the two solutions and add them together. But there is a really, really big shortcut here. A good formula to know is the sum of the solutions of a quadratic is always negative b over a. So in this problem, we got a, b, and c. Negative b is negative 6, and a is 3. That just gives us negative 2. And just like that, we get the answer. So it's a really good formula to know. But I understand that if it's a very specific formula and only works for this type of problem. So again, there's no solutions here. There's just trade-offs, and the trade-off for memorizing this particular formula would be if this problem shows up, then you'll solve it very, very quickly. Okay, but you could memorize formula and it just doesn't show up on your SAT. And that's another trade-off. And if you don't want to, then I would probably use Desmos and get the two answers and just add them together. And those will probably be decimals, but the it'll be close to -2. All right, so that works too. But again, the quickest way would be to just do this. But I do understand there's a lot of formulas to know, and if you don't want to spend time on this one, that totally makes sense as well. I'm just here to kind of give you all the information, and then you've got to decide for yourself what kind of works best. Okay. Moving on to number 5. Okay, so this is what I was talking about before. So if we look at kind of the hierarchy of solving these, the one would be tied between factoring and Desmos, I guess. Because Desmos is always going to be pretty easy to solve, to actually get the solutions. Factoring is pretty quick as well. When that doesn't work, I would try completing the square. And I'll explain, even though we know Desmos will always work, it's not always going to be useful, as I'll explain in this problem, it's not. And then our last ditch effort is the quadratic formula. It's kind of our hierarchy of solving quadratic equations. Now, let's look at factoring. Does this factor? Well, no, for two reasons. One reason is because you can't find factors of 40 that add to 12 or -40. But if you just look at all the answers, they have this square root in it, a square root of 19, which is an irrational number. It automatically doesn't factor once you see that. All right, so don't waste your time even trying to factor it. When you see the square root, it's going to mean that we're going to be doing completing the square or the quadratic formula. Now, the thing about Desmos is we certainly could plug this in and get the solution, the solutions using Desmos, but those solutions are going to be in decimal form. And then what we'd have to do is check all of these to see which one matches that. So that's why I think that might not be the best way. Desmos would be great if we could get either rational or or integer solutions. I don't think it's the best with the irrational. But again, you can do it that way. It's totally fine. But I want to make sure we know all the concepts. So now we go to completing the square. If we have an A value of 1 and a B value that's even, then completing square is, I believe, going to be quicker than the quadratic formula. Because all we have to do is throw the 40 on the other side. Completing the square is adding half of B squared. So half of B is 6. 6 squared is 36. And then this is W plus 6 squared equals 76. And here's the deal. You're going to square root both sides, all right? And then notice you're going to get W plus 6. You're going to have to subtract that 6 over. And it's not going to combine with your radical. So the answer at that point has to be D. So if you can do that, kind of stop the problem early and figure out that it has to be D, then that's going to be quicker than using Desmos and then checking all your answers, I believe. But just to show like why that works, the square root of 76 is clearly 2 root 19 if you just kind of look at your answers. But it is 4 times 19 and the square root of 4 is 2. So you get 2 root 19. Technically, there is a plus or minus. So when you subtract the 6, you get -6 plus or minus 2 root 19. And -6 plus 2 root 19 is one of those solutions. All right, so again, many ways to do these problems. You got to figure out which way kind of works best for you. It's all these trade-offs, whether you learn more ways to then be able to apply them, or some of us like to focus on, I'll just do factoring, and if that doesn't work, I'll use Desmos, and I'll, deal with the consequences. As long as you kind of like think about your strategy ahead of time, I'm kind of all for anything. Okay. All right. Number 6. This is again another one where we could easily use Desmos. All right. Throw it into Desmos and find the x value that's a minimum. You throw it into Desmos, you're going to get a parabola, and just find the x coordinate there. That should be simple enough. But I do want to go over a concept here that could be useful on a problem where they make it so that Desmos is difficult to use, maybe because it's yeah, I don't know. Well, I was going to say because it's open-ended, but even that, this one would be pretty easy to do in Desmos. But they can come up with clever ways to test these concepts so that Desmos is very, very difficult to use. So I want to go over the concept of, first of all, this, we were talking about standard form before. This is in what's called intercept form. So imagine you get your intercepts, and even though I didn't draw very well here, the vertex is going to be halfway between the intercepts because a parabola is symmetrical. All right. So, and something that's halfway in between two other points is simply just the average. So my x intercepts are where what makes each of these zero. So that is negative 15 and positive 4. So if I just quickly find the x-intercepts and then I add them up and divide by 2, that's going to give me the x-coordinate of the vertex. So that's just negative 11 over 2. So I feel like if you know that, you can do that in your head quicker than it would take to type this into Desmos. All right. I love using Desmos for a good amount of the problems, but I just want to make sure we have other ways to do these problems because the reality is a combination of using Desmos sometimes and doing it kind of like the more traditional way other times. Marrying those two together is what's going to ultimately, I think, give you the highest score because you'll save the most amount of time for those really hard problems at the end of that second module. Okay, let's keep it going. All right, so we've got number 7. This one, you could throw these values into Desmos. Let's just know that this is really the coordinate 2, 0. This is really 4, 0. This is really 0, 4. And they're basically saying, what's the y coordinate um, when I plug in 6. But I think it's easiest to just like imagine, just like sketching this out real quick on some scrap paper. So I got the point 2, 0. I got the point 4, 0. I got the point 0, 4. All right. And what we have, remember, a parabola is symmetrical. So if from the x-intercept, this x-intercept, I'm going 2 units this way, well, notice that 6 is just 2 units this way. So if I go 2 units this way and it gives me 4, when I go 2 units this way, it should also give you 4. So the answer is just 4. Remember, a parabola, let me try to draw this. I probably didn't do a great job. Not really, but a parabola is symmetrical. All right, so it's got this axis of symmetry here, and so again, so if we're on the x-intercepts, which are the same distance away, and we go 2 more units in each direction, they should give us the same y value. Okay, all right. Number 8, I want to go over a little bit of a longer way to do this, and then show you through that there was like a little bit of a quicker way. And a lot of times what we have trouble with is kind of how to get started. So we like read the whole problem and there's P's and Q's and R's and X's and, 2 possible values. And it seems a little confusing. So when that happens, just find a way to get started. So when I look at the left side, I could FOIL. Or if I look at the right side, I would think maybe I could factor. But factoring is going to be difficult not knowing what R is, but I can always FOIL. All right, so we're going to choose foiling. So if I FOIL, px times qx is pqx squared, and then px times 8 is 8px, 3 times qx is 3qx, and 3 times 8 is 24. And then what you do when it's equal to some other side, you just kind of match it up. So 6x squared is going to be this. These two are going to combine to rx, and obviously 24 is 24. All right, so you kind of match them up like this. Like these go together. These are the x terms that will combine to this. And again, 24 goes with 24. So what we're more concerned with is P and Q here. So this PQ equals 6. And it also tells us that P plus Q equals 5. That was given back here. Well, that's enough to do the problem. So the reality is I didn't need the rest. I just wanted to go through generally how you attack these problems. But in this problem, all we really needed was this first relationship. So we're looking for two numbers that multiply to 6 and add to 5. That's going to be 2 and 3. And since it could be 2 and 3 or 3 and 2, then the value of P itself could be 2 or 3. So the shorter way would have been to recognize that if we know P plus Q is 5, once we do the first step of FOIL, the PQX squared, that has to be 6x squared. That's all we really needed. So we didn't really need all of this. It was just worth going over that. And another problem you might, but again, trying to just do the parts of the problem necessary to get the answer, that's a little bit of a higher level that we can get to do these problems a little more quickly. All right, number 9, we've got the graph of the equation. Which of the following is the value of B? So one way to do this would be to use Desmos, use a slider, make B the four values, and see which graph matches this graph. But here, a little bit of a quicker way is to notice that the vertex is 1, 1. And when this is in standard form, the x coordinate of the vertex is negative b over 2a. Not to be confused earlier with the negative b over a formula, which was the sum of the solutions. The x coordinate of the vertex is negative b over 2a. And we know the x coordinate of the vertex is 1. So simply all we have to do is 1 equals negative b. Well, b here is b, so it's still negative b. And 2a is 2 times 2, which is 4. And then all we have to do is solve. So 4 equals negative b, which means b is negative 4. All right. So again, stopping like one step early or two steps early is another way to save time. So again, Desmos would work fine here, but I think that this way could be done, help you do it a little more quickly. Okay. Now we get back to types of solutions to a quadratic. They're saying that it has no real solutions. So that's the types of solutions, not asking for a specific solution. And when that happens, I would think immediately b squared minus 4ac, which is the discriminant. And when there's no solutions, the discriminant is going to be less than 0. So we're just going to solve this equation. All right. B is negative 34. Negative 34 squared is 1,156 minus 4 times A is 1 and C is C. So we're just going to take this and make it look like this. All right. They give you these other kind of like either inequalities or expressions in the problem that have multiple variables in it. Basically, just take what you have and try to get it to look like that. So I'm going to bring the 1156 to the other side so that it's negative 1156. And then here I have negative 4c. And then I'm going to divide each side by negative 4. That flips the sign to positive, and then I get 289. And when I match this up with this, I can see that I got my C, I got my greater than, N must be 289. As long as C is greater than 289, there will be no real solution. So the smallest value that N can be in that case is 289. But again, you don't even need to think that much about it. Just match this up with this, and N is clearly 289. This would be very difficult to do in Desmos because you don't have open-ended. You could do a slider, but the odds that you're going to like figure out that it's 289 from a slider without a multiple choice is I would either say highly unlikely, or if you really think you would do that, then you're probably spending a lot of extra time. All right, now on to number 11. So for this one, this one's a little bit tricky. So the first thing is we don't know exactly what this value is. So because the x-axis is not scaled. So that would be the vertex, but I can't use negative b over 2a here because again, I don't know that value and I don't know k. So then another way to find k is to realize that this crosses the x-axis once, which means there's one solution. And we talked about earlier, when you have one solution, b squared minus 4ac has to equal 0. So b is k, so k squared minus 4. A is negative half, and b is negative 2, and that should equal 0. So k squared, and then what ends up happening here is the negative half times negative 2 is 1. 1 times negative 4 is negative 4. And then we just get k squared equals 4. So this is really important. When you take the square root of each side, you really get a plus or minus 2. And the thing is, only one of those k's is actually going to shift it this way. I actually made a mistake when I first did this problem. I was thinking that if it were a left shift, then it should be positive 2, but the reality is this negative would eventually get factored out. It's kind of tricky with the transformation, so this is where I would probably use Desmos, and I'm not going to pull that up here, but if you graph this, y equals negative 1 half x squared plus 2x minus 2. So that's as if k were positive 2. That actually is going to look like this. And then if you graph y equals negative 1 half x squared minus 2x minus 2, that one is actually going to look like this. So that's how you can decide between the positive and the negative 2. So the answer to the problem is actually negative 2. All right? Let's move on. Now on to the last one, number 12. So this is our last form. We've talked about standard form tonight. We've talked about intercept form. Now we're on to vertex form. Vertex form. And the reason I know that is not only because I can look at all the answers, but it wants us to include the minimum values of x and y as constants or coefficients. Minimum is vertex, and if they want those as constants or coefficients, that's this form, because hk is the vertex. So the vertex is h comma k. Um, so these are the constants or coefficients of the problem where I could easily locate the vertex. So I want to use vertex form, and then I got to do my transformation. So it says if we take all I care about is the vertex here, and I take this graph and I move it by 2 units to the left and 4 units up. So the new vertex is negative 3, 1. Well, if I plug negative 3 for h, I get y equals, I don't know if there's an a or not, but it won't really matter. But then I have x minus negative 3. Well, that turns to x plus 3. And then plus k is plus 1. The only answer that has this in it is D. So that tells me A is 1. So I don't really have to worry about finding A. Okay, so this one, it's really helpful to know vertex form. All right. All right. Thank you for attending tonight. Make sure to check out our TikTok or YouTube for the other office hour videos or any of the other content we have. We do offer some tutoring if anybody's interested in that. And we will be having some courses coming up in the future too. Call or text or email if you want more information. Again, thanks for coming or watching.